China's 100 GHz light-powered chip ditches electricity, shatters speed record in computing. An international team of scientists led by researchers at the Peking University in China has designed a revolutionary all-optical chip that uses light to synchronize the speed of processors and can potentially reach 100 GHz clock speeds, media reports said. In comparison, conventional chips that use electricity have clock speeds of 2 to 3 GHz and have reached a peak at 6 GHz. The Central Processing Unit, CPU, is at the core of myriad computing devices that we see around us every day. From the smartphone, you might be reading this on, to artificial intelligence, AI, powered chatbots. Everything needs a processor that runs various functions in parallel to make the device work. The processor uses an internal clock signal to synchronize its internal functions, which also determines how quickly the processor works. This is typically measured in gigahertz, gigahertz, each giga representing a billion clock cycles per second. The higher the gigahertz of the processor, the greater its computing capabilities, and scientists have now managed to clock 100 gigahertz on this all-optic processor. According to Chang Lin, an assistant professor at the Institute of Information and Communication Technology at Peking University, conventional chips use electronic oscillators to generate clock signals. Limitations of this approach include too much power consumption, generation of excess heat, and inability to increase clock speeds significantly. So researchers turned to light as a medium to transmit and process information. Since light travels much faster than electricity, photons that generate these clock signals can process information faster. By building a ring that looks like a race course on the chip, the researchers ran light and used the time of each lap as a standard. Since photons travel at the speed of light, each lap takes only a few billionths of a second, and the clock can run at ultra-high speed. Conceptual illustration of a microcomb synchronized optoelectronic system. Image credit, Nature. Since conventional chips operate at a single clock speed, applications that cannot be synced at these speeds require different chip configurations, increasing the cost of manufacturing and computing. The researchers developed an on-chip microcomb that can synthesize both single-frequency and wideband signals, with the latter providing reference clocks for different electronic components in the system. On an 8-inch, 20 centimeters wafer, the researchers claim that they can make thousands of such chips, which can be used to deploy consumer-friendly solutions right away. For instance, the chip can be used to power mobile phone communication in both 5G and 6G network bands. More importantly, though, an upgrade in network speeds will not require an update in mobile phone hardware if the all-optic chip is used to power it. Similarly, using these chips in base stations would reduce equipment costs and energy usage. The higher clock speeds achieved with this chip would also mean faster computations that will power the development of artificial intelligence in a more energy-conservative manner. Application of the technology in autonomous driving could increase accuracy and response speed, the South China Morning Post said in its report.